Nice one. Yes, welcome to today's class. Today we are going to be learning about particulate nature of matter and valency and chemical formulas. Particulate nature of what? Matter. Particulate nature of matter, valency and what? Formula. This is a very important aspect in chemistry. Particulate nature of matter. Matter, as we all know, is anything that has mass and occupies what? Space. Anything that has mass and occupies space. Just as an example, water. The water you drink has mass and it occupies what? Space. Is what? Matter. But when we talk about particulate nature of matter, we're talking about those minute particles that make up matter. Those minute particles that make up what? Matter. When you continue to divide matter, at what point do you get to that you can no longer divide that matter? Is that clear? When you continue to reduce the amount of water, at what point is it the smallest? Talk about particulate what? Nature of what? Matter. Then at an advanced level, we're going to learn about valency and what? Chemical formula. Is that clear? Now, matter is anything. Matter is anything that has mass and occupies what? Space. It could be in the form of atoms, molecules, or what? Ions. Atoms, molecules, or what? Ions. We are going to be explaining this particulate nature of matter. You understand? The particle of matter can be in form of atoms, molecules, or what? Ions. Is that clear? That smallest, minutest part of matter could be in form of what? Atoms, molecule, or what? Ions. Now, what is an atom? An atom is the smallest indivisible particle of an element which can take part in a chemical reaction. Is that clear? The atom is the smallest indivisible part of an element which can take what in a what? Which can take part in a what? Chemical what? Reaction. Is that clear? It can take part in a chemical reaction. Now, there is this scientist known as Dalton. There is this scientist known as who? Dalton. He's an Englishman. I was the person that proposed the Dalton's atomic theory. He was the person that proposed what? Dalton's atomic theory. So we are going to look at this Dalton's atomic what? Theory. Dalton's atomic theory. We're going to be looking at it because it's a very important aspect of understanding what the atom is. This man is an English scientist and he did this in the year 1808. In the year what? 1808. English scientist known as Dalton. And what are the elements of his proposal? What are the contents of his proposal? He said that matter is made up of small indivisible particles called atoms. He said number one that what? Matter is made up of small indivisible particles called what? Atoms. So the first statement of Dalton's atomic theory is that what? Matter is made up of small indivisible particles known as what? Atom. Is that clear? That's the first thing he said. And the second is that atoms cannot be created and cannot be what? Destroyed. So the second statement says that atoms can neither be created nor destroyed. That's the second statement of Dalton, isn't it? But we know that this statement is no longer true. You understand? Most of the statements of Dalton's atomic theory are no longer true. But as a chemistry student, you need to understand them. You understand? Because they understood it, they now did more research and find out that most of these statements no longer hold true for now. You understand? But at the same time, it's good you know the statements of Dalton's atomic theory. Is that clear? That's the second statement that atoms can neither be created nor what? Destroyed. But through atomic fission, we now find out that atoms can actually be either created nor destroyed through nuclear reactions. You understand? But before then, all these statements held then. Is that clear? So let's forget about what is terrible now, but let's concentrate on this. That's on atomic what? Theory. The first statement is that every matter, me and you, are made up of small indivisible particles called what? Atoms. And the number two statement is that atoms can neither be created nor what? Destroyed. The number three statement says that atoms of a particular element are exactly alike in every respect and are different from other atoms of other elements. Number three statement says what? Atoms of a particular elements are exactly alike in every aspect, huh?
Yes.
In every aspect, but what?
Are different from atoms of other elements.
But are different from atom of other elements. That's the third statement of Dalton's atomic theory. That atoms, all atoms of copper are exactly the same thing. You understand? Whether you get the copper from here or from Abuja or from Lagos, it's still the same thing. You understand? But atoms of other elements, let's say magnesium, is always different from that of copper. You understand? But currently we know that this statement is now false, isn't it? With the advent or the discovery of isotopes, isotopy. You understand? Isotopy are atoms of the similar element, but they have different atomic numbers, so they are not the same. Is that clear? But before then, let's still hold for this, isn't it? Then the final and the last statement of Dalton's atomic theory says what? Chemical combinations are taking place between small whole number ratio atoms. That's what? Number 4 says what? Chemical combinations, you can call it reactions, are taking place between what? Small whole numbers. The law of simple proportion. Huh? Small whole number ratio what? Atoms. Law of simple proportions. We find out that most of these laws, most of these statements of Dalton's atomic theory have been proven wrong. Is that clear? But for you to have the proper understanding of atoms, it's good that you know these 4 statements of Dalton's atomic theory. It's good that you know what? These 4 statements of what? Dalton's atomic what? Theory. Is that clear? Is that clear? Good. Now, we are going to look at other particulate matter. We've learned about atom, isn't it? Now we look at what? Molecules and what? Molecules and what? Ions. Molecules and what? Ions. So first of all, we look at molecules. Molecules. What are molecules? The molecule is the smallest part of a substance, either an element or a compound, which can exist in a free state. Is that clear? The molecule is the smallest, isn't it? Smallest what? Smallest part of a substance. Part of a substance, whether an element or a what? Compound, which can do what? exists in a free state. Is that clear? A molecule can always exist in a free state, unlike an atom. An atom always exists in a combined form, whether with other atoms or with atoms of different elements. Is that clear? But you can always see a molecule existing on its own. A molecule can always exist on its own in a free state. Example is O2. Example is what? O2. Which is O2? Which element is that? Or which molecule is O2? This is oxygen molecule. You understand? It's very difficult for you to see in any chemical equation written, for you to see only O, which is oxygen atom. You understand? When you're writing any chemical equation, you always write oxygen as what? O2. Is that clear? Because oxygen is difficult for it to exist as a free oxygen. This oxygen atom, this oxygen molecule. You understand? So whenever it's taking part in a reaction, it's always in this form. In this form. Is that clear? Existing as a what? Molecule in a free state. So molecules, a molecule or the molecule is the smallest part of a substance, whether an element or a what? Compound, which can exist in a free state. Is that clear? An atom, when you're talking about an atom, you're talking about atom of elements. You understand? You cannot talk about atom of a compound. You talk about molecule of a compound. Is that clear? But you can talk about an atom of an element. You can also talk about molecule of an what? Element. Is that clear? Is that clear? Is that clear? So whenever you see something written like this, O2 or Cl2, can you call this an atom or a molecule? Molecule is the only molecule that exists in this form. When you have only Cl, then you call this a what? Atom. Is that clear? But you can hardly see this in a free state. Is that clear? It's easier for you to see the molecule existing in a free state, ready to combine or be reacted with other reactants. Is that clear? Now we look at what we call ions. We look at what we call what? Ions. What are ions? Ions. An ion is any atom or group of atoms which possess an electric what? Charge. You understand? Any atom or group of atoms which possess electric what? Charge. That's what atom is. And that is the normal state when there is reaction of when you have what we call ionic combinations. Is that clear? Is that clear? There are two types of these ions. We have the positively charged one, known as cations, and the negatively charged one, known as what? Anions. So we have two types of ions. We have number one, we have the what we call cations, which are what? Positively charged atoms. You understand? Then we have what we call anion, which are what? Negatively charged atoms. You understand? You are going to find out that cations are normally for metals, whereas anions are normally for what? Non-metals. Normally for what? Non-metals. Example of cation is sodium Na+. You must have plus. This plus indicates that it is what? Electrically what? Charged. Any atom, this is the atom, sodium, or group of atoms which possesses what? Electric charge. That's the plus on top. Is that clear? Other examples are calcium 2+. Is that clear? Then we have iron Fe3. Then examples of cation anions are Cl minus bar, that is chlorine, and NO2 minus. This is an example of group of atoms. This one is just one atom, group of atoms having an electric charge. That is an ion. Is that clear? Nice one. So there are some phenomena that help prove the particulate nature of matter. That help prove what? That matter is actually consisting of small particles. And those phenomena are known as what? Number one, we have what? Diffusion. Number two, we have what? Osmosis. Three, what? Evaporation. Which other one? Sublimation and what? And number five, what? Brownian motion. Is that clear? All these phenomena happen in particulate state. Is that clear? These are all evidence of particulate nature of what? Matter. These are the evidence. You understand? In subsequent class, we are going to be learning the definition of diffusion, movement from area of higher concentration to that of lower. Osmosis, evaporation, sublimation, and Brownian motion. Brownian motion simply means zigzag motion of particles. So we are going to explain them in subsequent classes.